Okay, hello everybody. Today we're going to be modeling a static mixer in Ansys Fluent. For those of you that don't know what a static mixer is, it's essentially just a device that takes either two fluids or even possibly two different small solids, different fluids at different temperatures, and mixes them using non-moving parts. It uses a set of baffles that direct the fluid across from each other, causing turbulent flow, mixing the fluids together without any mechanical energy inputted. The mixing energy comes from the pressure drop across the device. So we're going to start today in Fluent. We're going to start with the geometry. So you're just going to click on Fluent, go to Geometry, right click, and we're going to use Design Modeler. Okay, so in Design Modeler, we're going to go to units. We're going to change it to millimeters because we're going to be working in millimeters. We're going to go to the XY plane, and I like to set up my grid just a certain way. You don't have to do it this way, but we make our major grid spacing 100 and our minor steps 10 millimeters. Next, we're going to draw a rectangle about the center of the grid. We're not too worried about that because we're going to come in and use our symmetry constraint to center that rectangle directly over the origin. We're going to center it based on the y-axis and then again along the x. This is going to be important later when we create the 3D geometry. Alright, so here we're going to dimension it. It's going to be 100 millimeters long and 5 millimeters thick. So this is going to be the profile we're going to use for our 3D geometry. Next, we're going to go to the YZ plane and we're going to draw our path line. So this is just going to be a straight line along the z-axis, and then we're going to end up dimensioning it. And this is going to be 200 millimeters. So we're going to go and do that right now. Okay, so now we have our two sketches. We're going to make sure we can see both of them. Show sketch. And then we're going to go and we're going to use the sweep function. We're going to sweep that rectangular profile along that path. So for our profile, we're going to click sketch 1. For the path, sketch 2. We're going to make sure we use the add frozen operation. We're going to add twist, and we're going to use the number of turns to determine it, and we're going to do half a turn. So then go and click generate, and there we go. We've got our first baffle profile. It's just similar to like a spiral. So we're going to go in and we're going to use our body transformations to mirror this across the XY plane. Make sure you select the body and then the plane and then generate. Okay, so there we go. We've got two separate baffles, but we need to rotate the second one we just mirrored. So we're going to do another body transformation and we're going to rotate it 90 degrees. And for our axis, we're going to use that path line we used earlier. This is how the mixer actually directs the flow back into each other with 90-degree turns. So you can just see a little bit of the geometry there, get an idea of what it's going to look like and how that fluid's actually going to flow through. So we're going to use a Boolean function and we're going to unite these so that they're one solid body. But this is just one set, right? So in a static mixer, you're going to have many sets of baffles to increase the mixing. So what we're going to do here is we're going to pattern it. We're going to use a linear pattern and we're going to use that same path line as our axis. Now you're going to have to make your offset 400 millimeters, and then we're really going to do 2 copies. I accidentally typed 3 there, but we're going to change that. We're going to do 2 copies to where you have 3 sets or 6 total baffles. and you can see it right there. So we need to do one more function. We need to go in and create a Boolean and unite all these together to where it's one solid object. Generate, and there we go. So now that's the figures of the baffles of the mixer. But what we actually need to model is the flow domain, or where the fluid's actually going to be traveling. So what we're going to do is we're going to model a cylinder and then subtract those baffles from it using the Boolean function to create our flow domain. So we're going to go in back to the XY plane, draw this circle with a diameter of 100 millimeters, and then we're going to use the extrude function. So since the sketch is on the XY plane, we have bodies on both sides, we're going to have to use the asymmetric extruding. So F1 is going to be 300 millimeters and F2 will be 1100. That gives us an extra 100 millimeters on either end of it to let the flow kind of come back together. So again, we're going to use a Boolean, and we're going to do what I talked about earlier. We're going to subtract those baffles from it to create our flow domain. Tool body is going to be the baffles and generate. All right, so now those baffles have been subtracted. The last thing we need to do is we need to split the inlet face so that we can inlet either two different fluids or the same fluid at even different temperatures. So we have two different faces that we can identify. So we're going to create a plane on that face, and then we're going to come in and draw a line along, splitting the face in half. Now I went a little over, and we'll trim it back up. There you go. We'll hide the body so you can see. All right, so you're going to go to Tools, and you're going to click Face Split. Now, target face, we're going to have to select the front face of that cylinder. And then for the tool geometry, you're going to go and you're going to click the points, the endpoints of that line we drew. And boom, you see it highlights that dividing line. Now we're going to generate. We'll show the body again. And here you can see now we have two individual faces. All right. So we're just going to save our project real quick in case there's any errors later on. Just call it static mixer. And boom. Okay. So the geometry is done. Now we need to move on to the meshing. So the meshing is going to be pretty simple. We're not trying to looking to get too complicated here. We're just going to do a standard mesh and a little bit of refinement. Once this loads, at least. Okay, so you're going to click your mesh, click generate. This will just give us a base solid mesh. So it's not too bad, but we definitely would like some refinement. So we're going to select all of our faces here. And we're just going to add a little bit of refinement. We'll say level 2 and generate. All right, that looks nice, even, very small elements. Okay, so now we need to create our name selection. So we're gonna click on the left inlet, and that's gonna be our cold inlet. We're going to do the right side. That'll be our hot inlet. We're going to go use the outlet. And then we're just going to do name the whole body as the flow domain or the fluid domain. Fluid domain. Okay. So update and save project. So now we can move on to setup. All right, so now that we've completed our mesh, we have our geometry, we're going to go ahead and move on to the setup. So we're going to use a double precision and we're going to use parallel processing. Now, I'm going to use 6 processes, but that will change based on the number of cores in your CPU. So we're going to launch. All right, so here we go. We've got our model. So we're going to use a steady state for this, but we're going to make sure we turn on energy under models. And we're also going to use a turbulent viscous model. So we're going to use K epsilon here. And we're just going to keep these standard values. So, okay. Now, we're going to use 2 different temperature inlets. We're going to use a cold and a hot. And we're going to use water as our material. So we're going to come down here to materials, go under fluids. We're going to have to use the database. So we're going to click the Fluent database. And we're going to scroll all the way to the bottom where it's liquid water. So we're going to click copy and close, change. Okay, so now we need to ensure that we're actually going to be using that material. So we're going to come to cell zones, and then we're just going to change right here, water. Okay, so now we've got boundary conditions. So as I said, we're going to use 2 different temperatures. So we're going to take our cold, and we're going to use, we're going to make it 1 meter per second velocity. And we're going to come in here and we're going to do 290 Kelvin for the cold inlet. And again, 1 meter per second and 360 Kelvin for the hot. So now we've got those. We're going to come down to methods and we're going to change these 2 to second order. This is all just based on the calculations we're going to be making with the turbulence. Okay, so we got to come to monitors and we're going to change our residuals to monitor. Just give us a little more accurate representation. Okay. And we're going to use a hybrid initialization. So we're going to come to initialization. We've already got hybrid selected. Initialize. And now we just have to run it. Now we're going to do 4,000 iterations just to be safe. Make sure we have a nice steady result. So calculate. Okay, so after your results are calculated, we're going to come into our results tab here and we're going to find out a little bit about our contours. So we're going to do just a static pressure contour. And you can see this is going to be your inlets. Here's your outlet. There's a pretty significant pressure drop across the mixer, and that's the purpose of it, right? That's where you're getting that energy to actually mix the fluids together. So that's pretty neat. So we're going to come in here. We're also going to add a second contour. We're going to do a temperature contour so you can see a little bit how those 2 different fluids are mixing together. So here you can see you've got hot inlet and your cold inlet. And you can see after about a baffle and a half, it's very well mixed. The temperature's pretty steady. Now there is a little bit of deviation in there, and we'll be able to see that later when we put a plane and see the cross section of it. but pretty neat to look at. And then finally, we're gonna add our velocity vectors and just see how they end up looking. So you can see it's pretty dense, but you can see at the edges of each of those baffle cuts, the velocity is very slow. It's building up pressure around there. And then at the interchanges, you get a significant boost. Okay, guys. So we've completed any results we're gonna use here. So we're gonna go ahead and we're gonna save this project. Make sure we're good there. We're gonna leave and we're gonna go to our next results section out of Workbench. So we're gonna come right here. And this is where we're gonna do our streamlines I spoke about. So you're gonna come up here, you're gonna choose Streamline. You can just name it Streamline 1. Now we're gonna make sure we start from both inlets. So we want to choose hot and cold. We're going to increase this number of points to 200. I like to make the symbol smaller, just it's easier to see. And we're going to go ahead and click apply. So you can notice a few things, right? The streamlines only go through about 2 of the baffles and then they disappear. Well, this is because the streamlines are based off of velocity averages. So streamlines are really for laminar flow. The purpose of this device is to create turbulent flow and to mix fluids. So after the second baffle, the flow is essentially completely turbulent. So you can see at the beginning, they're very dense. As you enter the first baffle, they start to be directed, and when they get to this intersection here, the streamlines drop off significantly. And again, by the end of the second baffle, there's essentially nothing left. All of this is completely turbulent flow. So what we can do just to get a little bit better understanding is we can actually animate this. So we'll click Streamline 1. We're going to make sure it's slow, that way it's easy to see, and we're going to change that symbol size again, just to where it's easier to see everything. So we'll put it on loop and click play. So again, you can see they start off fast, right? They go into that baffle, start to change direction as the baffle directs them, and when they get to that intersection, they slow up quite a bit and drop off. And then you just have a few streamlines continuing past that. So we're going to go ahead and pause this. It only takes a little while. Okay. So what we're going to do next is we're going to create the plane along the center of the mixer. That way we can look at our pressure and temperature contours in the center of the mixer. So we're going to come here to location. We're going to choose plane. And what we're going to do is we're going to create a plane parallel to the ZY plane. So for method, I'm going to click YZ. And then for distance, it's actually centered at x equals 0. So we don't have to change anything there. We can just click apply, and that will create our plane right here. So now we're going to go back up, find our contours. Okay. So going to make sure it includes all of our locations. Okay. Pressure, we're going to do pressure first. Actually, I lied to you there. You got to make sure your location is plane 1. Now we're going to click apply. And we can hide these streamlines where it's a little bit easier to see. Okay, so this is essentially the cross section of the device. These lines here is basically where your baffles are, so you can see the separation. Now, you can see the pressure drops significantly again, and it's kind of in stages. It's really well defined there, but this just gives you a little bit better picture, better understanding of what's actually going on. Now we're going to go ahead and add a second contour here, and we're going to do temperature again. And we're going to hide this first contour so it's a little bit easier to see. So again, right, the temperature, the two fluids mix very quickly, and since energy, heat energy can, transfer much easier than actually the fluids mixing, it happens faster. Whereas if you had two separate fluids, the mixing would continue throughout. But most of the mixing happens right here in this first baffle for the two different temperature fluids. So you can see your temperature contours there, and then as you progress throughout, it evens out quite a bit to here at the end. But there still is a little bit of deviation there, just as the fluids are crossing the paths back and forth. So that's pretty much it as far as results. We did do a second simulation using a different turbulence model, viscous model, and I will put those results here at the end just for y'all to see. So go ahead, try this out. Maybe test it with different numbers, different materials, whatever you like, and just practice, Ansys Fluent a little bit. So thank y'all for watching. Y'all have a great day.